Okay, so this is the first video for 5.3. We are going to start graphing radical functions. And our essential question for this unit, or for this section, is what are the characteristics of a radical function? So let's visit those. Okay? Well, first we need to know what is a radical function. And it is a function containing a radical expression with the independent variable in the radicand. So that means inside under the radical symbol. Okay? And we need to first visit what these parent functions are. The parent functions for square root and cube root look like this. Okay? And we're going to kind of address these in these first two problems that we're going to talk about. So this is on your notes, but let's go ahead and graph. Describe transformations in graph. Well, there's no transformations to describe on these first ones because they're the parent function. Okay, so this is the parent function of a square root. So what we first need to do is figure out the points to plot. So I'm going to make a little chart. Remember, the y value is whatever this is. So I take x and I'm going to square root it. Okay? So I need to find values of x that I can take a square root of. I can't take a square root of a negative number, so I'm not going to have any negative x's. I can take a square root of 0, and I get 0. I can take a square root of 1, and I get 1. Square root of 2 is a decimal, so I'm not going to do that. Square root of 3 is a decimal, but I can take a square root of 4 and get 2. And I can take a square root, the next one would be 9, and get 3. And you can keep going. Square root of 16 is 4. And so forth. Notice these points are just the same as when we did the quadratic, only we switched our x and y, and then there's no negative x. So if I plot these at 0, 0, 1, 1, 4, 2, and 9, 3, our parent function looks like this. And I always describe this one as an eyebrow. It's the eyebrow graph. Okay. So, there is no transformation because that's the parent function. That's what it looks like when there's no transformation being performed on it. It does want us to name the domain. Okay, domain are all the possible x values. So it looks like it's going to start at 0 and go to the right forever. So that is when x is greater than or equal to 0. That's how Big Ideas will have it entered. But you can also write it in interval notation, and it includes 0 and goes to infinity and would look like that. And then we need our range, which are those y values of our graph. Again, it doesn't go below the x-axis, so it's starting at 0 and it's going up forever. So it's going to be y is greater than or equal to 0, and in interval notation, it looks the same as the domain. Alright, so let's try the next parent function, a cube root. Okay? So again, this is a parent function. We need to come up with our table. And remember, the y value is the cube root of x. So whatever x is, I'm going to take the cube root of it, and that's how I get y. Well, you can cube root negative numbers. So I need to find a value of x that I can take a cube root of and get a nice whole number, and I can cube root negative 8, and I get negative 2. The cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. And then the cube root of 8 is 2. Notice the y value, since I'm taking a radical of these values of x. If you square, or in this case, cube, so if I square the y values in this parent function is the same as if I cube the x or y values in this function to get the x's. So you can kind of work from the right to the left, but if you're having trouble figuring out what you could take a cube root of. But if I plot these, I get these points, and it looks like this. Okay? This one looks like the cubic graph, only sideways and reflected, but so now we need our domain. all the values of x, well, it's going left and right forever, so it's going to be all real numbers. I'm going to abbreviate that. Now, you could also do that as the algebraic symbol, all real numbers. Looks like that. Okay, if we wrote it in interval notation, it would be negative infinity to infinity. Okay, the range are all the values of y. Well, the arrows go forever down and forever up. So again, it's all real numbers, which you could write it like that, or you could write it like this. Okay? All right, so I'm going to end this first video, and in the next video, we're going to start actually doing some transformations.